Have you ever walked into a control room, looked around at everything running, and thought, this whole thing feels harder to manage than it should? Nothing's completely failed. The equipment's running, alarms are coming in, but somehow, it just feels like a mess. Like everyone's treading water. If that sounds familiar, you're not alone. And in 36 years working in industrial controls, I can tell you, that feeling is almost always telling you something real. So today, I want to discuss the 3 things that slowly turn a decent control system into one that's a nightmare to live with: configuration, architecture, change. These 3 things, on their own or working together, are behind most of the dysfunction I've seen in ICS environments. By the end of this video, you're going to understand exactly how each one shows up in the real world and what you can actually do about it. But first, let's talk about what broken actually means. Because here's the thing, broken doesn't always mean down. A lot of people picture a broken system as one that's not running. Lights out, equipment stopped, total failure. But in the ICS world, that's actually the easy kind of broken. Because at least you know something's wrong. The kind of broken I'm talking about is sneakier. Your system's running. Things are producing. But it's hard to troubleshoot. It's inconsistent from area to area. You're afraid to touch old code. Every change feels risky. And if you lost your 2 most experienced people tomorrow, you'd be in serious trouble. Here's how I think about it. If every change feels dangerous, every problem takes too long to solve, and only 1 or 2 people really understand the system, then that system is already showing signs of being broken, even if it's technically running right now. Okay? So keep that in mind as we go through this topic. Alright, part 1. Configuration. Now here's something I see trip people up constantly. A lot of systems aren't failing because of bad hardware. They're suffering from poor, inconsistent configuration. And those are 2 very different problems. Think about it this way. You've got 10 similar pumps across a facility, same manufacturer, same model. But 5 of them were set up by one integrator 5 years ago, and the other 5 were set up by a different contractor 2 years after that. Each group did things slightly different. Different tag naming, different alarm limits, different HMI faceplate behavior. Some had bypasses put in for startup and never removed. Now multiply that across 15 years of different contractors, different projects, different programmers. And what do you get? A system where nothing is quite predictable. That's the real cost of configuration drift. Troubleshooting slows down because you can't assume anything. You've got to verify everything from scratch because the setup isn't consistent. I've been in facilities where a senior tech would walk me through a problem and say, yeah, this section was done by so-and-so, so it works differently than the rest. That knowledge shouldn't live only in someone's head. And it's not just PLC programming styles. I'm talking about alarm limits that haven't been updated to match how operations actually runs. User accounts and permissions that nobody's reviewed in years. HMI screens that look completely different from one building to the next for no good reason. Inconsistent field device settings across equipment that should be identical. Individually, each of those things might seem minor, but pile them up over time. Even if every individual piece works, the system becomes harder and harder to trust. Every technician develops their own mental map. And when that person leaves, so does the map. Okay, part 2, architecture. Now here's the thing. Even really good configuration can't fully save a system with weak architecture underneath it. They go hand in hand. And this is where it gets interesting, because a lot of facilities didn't start with bad architecture. They evolved into one, project by project, decision by decision. Every time there was a budget or a capacity expansion, or a new vendor came in with their platform, something got bolted on at the time. Each of those decisions made sense locally. Solved a specific problem, got the project done. But here's what happens over time. You end up with systems built in phases with no long-term plan holding them together. Too many platforms, too many vendors, poor separation between layers, your OT and IT bleeding together in ways nobody planned. You've got duplicated functions split between your Scada, your historian, your PLC, and 3 different third-party tools that all kind of do the same thing. And nobody ever stopped to draw a line and say, this is what our target architecture looks like. This is where we're heading. So what do you end up with? Patchwork. Every upgrade gets harder, every integration takes longer. Your best engineer spends half their time just untangling what connects to what. Here's the thing about architecture problems. They don't hurt right away. That's what makes them dangerous. They show up later, as complexity, as brittleness, as rising life cycle costs that nobody can explain, as a replacement project that was supposed to take 6 months and ends up taking 2 years. Because the existing system is so tangled, nobody fully understands it anymore. I've seen it more than once. And part 3, change. This one, honestly, this is where a lot of good systems start to fall apart. And I feel strongly about this. Look, change is constant in industrial environments. Equipment gets upgraded, processes shift, new requirements come in. You're never going to stop change from happening, and you shouldn't. Change is how systems improve. The problem isn't change itself. The problem is uncontrolled, undocumented, poorly governed change. You know what I see all the time? Emergency edits made directly in production, under pressure, with no proper review. Nobody had time to write it up, so it didn't get documented. Drawings never updated. PLC logic modified. Backed up incorrectly. Now nobody's quite sure which version is actually running in the field. Contractors come in, do their work, leave. And they did it their way, which is different from your way. And neither of those ways got written up properly. And then your most experienced person retires. Or moves on. And they take a decades of undocumented system knowledge right out the door with them. Here's the line I want you to hear. Most broken systems are not systems that were designed badly once. They're systems that were changed hundreds of times without enough discipline around each change. That's the real story. Now here's where it gets crucial, because these 3 problems don't just exist in isolation, they reinforce each other. Weak architecture makes configuration harder to standardize. If your systems are fragmented, different platforms, no clear design intent, there's no solid foundation to build consistency on. So configuration drift almost becomes inevitable. Poor configuration makes every future change riskier. If you can't trust the baseline, every modification becomes an adventure. You're always second-guessing what the current state actually is. An unmanaged change, it slowly erodes both. Every undocumented edit makes your configuration less trustworthy. Every project that bolts something on without checking the architecture makes the overall design a little weaker. So you can't just fix one of these and call it done. You've got to look at all 3. They're connected. So what does all of this actually look like in a real facility? Let me paint the picture. Operators don't trust the alarms. There are so many nuisance alarms, or alarms that have been wrong so long that people start ignoring them. That's dangerous. Really dangerous. Maintenance staff work around the system instead of with it. They've learned that the system can't be trusted for certain things, so they develop their own workarounds. And those workarounds never get documented either. So now you've got tribal knowledge built on top of tribal knowledge. Engineers are afraid to touch old code. I've heard this more times than I can count. Oh, we don't go into that section. Nobody knows what it does. That shouldn't be acceptable. But I get it. I've been there. Similar assets behave differently for no obvious reason. Nobody's sure which set of drawings is actually current. Upgrades take twice as long as they should, because the first 2 weeks are just spent figuring out what's actually there. And troubleshooting? It depends entirely on one veteran person who carries the whole system in their head. When a system becomes dependent on memory instead of standards, that's usually the sign that drift has already taken hold. Serious drift. Okay, so what do you actually do about it? And I want to be really clear here. I'm not talking about tearing everything down and starting over. That's rarely practical, and honestly, it's often not necessary. What I'm talking about is regaining control of the system lifecycle. And you do that gradually, deliberately. First, standardize configurations where you can. Define your naming conventions. Document your alarm philosophy. Set a programming standard and actually use it going forward. Even if the old stuff is messy, you can stop making new messes starting today. Second, define a target architecture. Even if you can't get there tomorrow, you need to know where you're going. Every project decision should be checked against that target. Is this moving us toward where we want to be? Or further away? That question alone will change how you evaluate projects. Third, use proper management of change. And I don't mean just a form for compliance. I mean a real process where changes get reviewed, documented, and the drawings and records get updated as part of the work. Not later. As part of the work. That's the discipline that stops the drift. And fourth, treat technical debt as something you actively manage, not just something you react to when it causes a failure. Build regular reviews into how your team operates. Make it part of the rhythm. This isn't about blaming past decisions. Most of those decisions made sense at the time. It's about choosing to do things differently going forward. So here's the bottom line. Industrial control systems usually don't become broken because of one device, one bug, or one bad decision. They become broken gradually through configuration drift, through weak or fragmented architecture, and through unmanaged change. And those three things feed each other in ways that make the whole system harder and harder to live with over time. If your system feels harder to maintain than it should, ask yourself, is the real issue configuration, architecture, change, or honestly, all three? I'd love to know what you're seeing out there. Drop a comment below. Which of these three causes the most trouble in your facility? Configuration, architecture, change? I read every single one. If this was useful, hit the thumbs up. It genuinely helps this channel reach more people in the industry. And subscribe if you want more practical content like this. I've got a lot more coming. Thanks for watching. I'll see you in the next one.